Alright, we need to break down this topic, designing and developing assessments. First, let's talk about Table of Specification or TOS. What its role in assessment design?
The TOS is like a blueprint for test construction. It ensures that our assessments align with learning objectives and have balanced distribution of questions across different cognitive levels. Without it, we risk creating a test that focuses too much on recall instead of higher order thinking skills.
That makes sense. But how do we actually construct a TOS? What should we include?
Great question. We start by identifying the learning objectives and the corresponding content areas. Then, we determine the cognitive levels based on Bloom's taxonomy. Remembering, understanding, applying, analyzing, evaluating, and creating. Finally, we distribute test items proportionally to reflect the emphasis on given to each topic.
Let's take an example. Suppose we are assessing, designing, and developing assessments. What should our TOS look like?
Well, we need to ensure our questions align with our learning objectives, which are developing assessment tools that are learner appropriate and target match, and improving assessment tools based on assessment data. How do we convert these into a well-structured TOS?
We should first define the topics. TOS, reliability and validity. Next, we determine how many questions should test lower order thinking skills or lots, like remembering and understanding, and how many should assess higher order thinking skills or HOTS like application, analysis, evaluation, and creation.
So, a well-structured TOS could have 30% of the items assessing lots and 70% focusing on HOTS, since assessment development requires deep thinking. What's the ideal way to distribute these questions across different formats, multiple choice, essays, performance tasks?
That depends on the nature of learning. If you want to assess a student's ability to apply assessments concepts, performance-based tasks like test construction or item analysis would be ideal. Multiple choice questions, on the other hand, are useful for testing fundamental understanding.
Exactly. Now, let's connect this to reliability. How does TOS contribute to test reliability?
Reliability is about consistency. If we construct a test using a well-designed TOS, we ensure a balanced and fair assessment. This prevents situations where some topics are overrepresented while others are barely tested. Inconsistent testing leads to unreliable results.
That means if students take the same test at different times or under different conditions, their scores should remain stable. But reliability also depends on the type of reliability measure we use. Would KR220 or test-retest reliability be more applicable here?
Good question. KR20 or Kuder-Richardson Formula 20 is best when we have a binary scoring system, right or wrong answers. But if we want to test stability over time, the test-retest method would be ideal.
So, if we design an assessment using TOS and ensure reliable test items, we need to check validity next. How do we guarantee validity in our assessment tools?
Validity ensures that our test actually measures what it's supposed to measure. If our learning objective is about designing assessment tools, but our test only asks about the definition of TOS, then we have a validity problem.
That's why we have different types of validity: content validity, construct validity, and criterion validity. Which one do you think is most important in our case?
Content validity is crucial because we need to make sure our test covers the intended learning objectives. If we forget to include questions on validity and reliability while assessing assessment design, our test lacks content validity.
What about construct validity? Does it apply here?
Yes, construct validity ensures that our test actually reflects the theoretical concept we are measuring. For instance, we claim that our test assesses students' ability to develop assessments, but we only use multiple choice questions. That's questionable construct validity. We might need performance-based tasks instead.
That's a good point. Now, let's talk about improving assessment tools based on assessment data. How do we use data to refine our tests?
Item analysis helps. If a test item has a very high difficulty index, meaning most students get it wrong, it might be too hard or unclear. On the other hand, if almost everyone gets it right, it might be too easy.
That's where discrimination index comes in. If high achieving students and low achieving students perform the same on a question, the item might not be distinguishing students' ability well.
So, after analyzing test data, we can remove bad items, revise unclear ones, and add more balanced questions to improve assessment quality.
But how do we ensure our revised test remains reliable and valid?
We need to pilot test the improved version. Administer it to a small group of students, analyze results, and check for reliability and validity again. If the scores remain consistent and truly measure what we intend, we can finalize the test.
That makes sense. To summarize, first, TOS helps ensure fair test construction by aligning questions with learning objectives. Second, reliability ensures consistency in test results. Third, validity ensures our test measures what it claims to measure. Fourth, assessment data helps refine and improve test items.
And all of these steps ensure that our assessments are learner appropriate and target match, which fulfills our learning objective.
This was a great discussion. We've covered TOS, reliability and validity, and data-driven improvements. Now, let's apply these concepts by constructing our own TOS and test items for practice.